Hi, Krishna. Morning.
Hi everyone. Good morning.
Good morning, Krishna. Got a little bit delayed due to our last session, but we will pick it up from here. Um,
Okay.
yes. Thank you for keeping your camera feed on. We would like that on for the rest of the session.
Sure.
Yeah. So let me give a quick intro before you start the session. Welcome back. Moving right along with our second session of the day, which is a workshop presented by Krishnav Dave, the principal data scientist at Great Learning. And in today's workshop, he's going to cover how raw functional data stored in a database can be used to build an AI or ML enabled prediction model, which will be followed by a clickable application and decision dashboard. Very interesting, Krishna. Krishna has a proven track record of designing and deploying best-in-class learning curricula on AI and work for working professionals. He has also 8 years of industry experience in machine learning, deep learning, AI, automation bots, virtualization, process automation, and business analysis. So let me not take up much time. We can begin the workshop. Welcome, Krishna. I'll stop sharing the screen so that you can take over.
Okay. Perfect. Thank you for that introduction, and I hope my room is well lit. I'm not sure if that's okay. I'm visible. There might be a little fluctuation sometimes on the bandwidth part, where I would request to switch off the camera. But yes, during the time I'll try to balance it. Please do let me know if my screen is visible now to everybody.
Yes, Krishna, it is.
Yes.
Yeah.
And a quick check, how am I going to interact with the participants? That is by the chat section, or we'll be having the mics also on?
The mics will not be on for the session. However, they can write all their queries on the chat box. Also, they can post their queries at the end of the session on the Q&A. So whenever you would like to take that up at your convenience.
Great. All right, I got it. Thank you. Okay. Good morning, everyone. Let's start with the session. And yeah, so what are we going to do today is, just give me a minute. I'll try to minimize things on the screen. Yeah. Good morning, everyone. I hope everybody is fit and fine, and everybody's doing good. What are we going to do today is we are going to have a semi-workshop, right? Where I will, first of all, I'll introduce you to what is AI/ML, because there could be an audience who is new to AI/ML, or there could be an audience who's already working into analytics, data science, or AI domain. So keeping everybody in mind, we'll start with a basic introduction of AI, what exactly is AI, and then towards the end of the session, we are going to build a working clickable app, right? So I'm going to take you through the complete full stack journey of how do we fetch the data and how do we convert that into a business application. Okay. And also you will often see me, scribbling on the presentation. I'm really sorry if, that's not visible. Do let me know. I usually make my sessions more interactive, and also just to highlight that what am I talking about from the PPT. It'll be helpful for everybody to pinpoint the location that we are talking about. Okay. Okay, so I welcome everybody to this workshop. About me, I think already an introduction is given. Basically, I am a deep learning expert with close to 9 years of experience now onto deep learning and IT services. I am a professional Scrum Master, certified Scrum Master, an Agilist. And also I started my career as a development and a tester, so a full stack developer role. And I'm a certified test automation and RPA expert. So overall, my experience is majorly onto building automations and powered by, basically now when I'm into AI, I power it with AI and I make a full stack working applications, right? So this is about me. About the session plan. So before I move on to the session plan, you would see me switching between this PPT. There is a whiteboard that I usually use to explain stuff. And also you might see me running certain codes on a Python environment. But again, I don't expect all of you to go through the codes, but yes, when I run it, just be patient with me. The reason I'm running it just to pop up the live application, so that in a clickable application, so that I'll be able to coincide the things that are written on the PPT along with the Python code. Okay, great. So as I said, what are we going to do today is I'm going to introduce all of you to AI/ML, a very, very simplistic introduction to AI. And probably after this introduction, everybody would be very clear what exactly AI does and how exactly AI does that thing. Okay. Then we are going to spend a good amount of time understanding what are the different domains and applications of AI/ML. So I'm going to introduce 2 or 3 domains, and down the line, I know you can correlate with your own industry or with your own area of expertise, how you can put these decision-making models in your area. Yep. Post that, we are going to talk about the full stack AI/ML ecosystem. That is how basically a raw data is designed, collected, cleaned, how that is put into an AI/ML model, how it is tested, and how it is deployed on a production environment, right? So I'll try to simplify the complete process for you. Now, again, a heads up for all of you about this particular section is there are hundreds of ways in which you can do these. I'm going to show you the simplest way, the place from where you can get started. And then depending on your organization, your ecosystem, available tools, you can scale it up. So please don't expect it or probably baseline it that's it as deployment. No, there are hundreds of ways in which different organizations do it. Followed by a Q&A. So I'll give a fair amount of 15-20 minutes of time where I'll keep it open for the questions part of it. And I would appreciate everybody that to be patient with me, to push your questions on the Q&A section in the chat window. I'll pick those questions up during during this particular section. Right. So any questions that you have, technical or probably on the job roles or shiftings and all, I'll be happy to answer in this section. And down the line, I'm going to conclude the entire session with one small ending note where, how you can break the ice and start applying AI into, or probably start learning AI and start applying in your domain. Yeah. So this is the overall agenda. From the timing part, what are we going to do is we will spend a good amount of close to 1 hour onto this part where I'm going to show you how to build it, and remaining we'll try to adjust within 10 to 15 minutes of the time. Yeah, great. So I'll just keep my screen as full now. Just give me a minute. Great. A quick check. Are you able to read the text? Because I am. I'm not sure how it looks like when it is on the screen sharing. Okay, great. All right. Okay, I got some answers as yes. Okay, so as I said, every session, so probably whenever I take a mentor session or whenever I'm doing these kind of live workshops, it is very important for everybody to understand the outcome, right? So I usually don't make slides with a lot of text or probably a lot of pictures and all those things. It's a very simple thing. What are we going to do is at the end of the session, each one of you will be able to probably fix what exactly is AI/ML. So if down the line post session, if you pick up a data, you would be able to understand how do I apply AI/ML onto this data and make some decision out of it. And also, if anybody is interested or probably is looking for a full stack role, right, I'll enable all of you how exactly you can push these decisions onto a live application. It can be a web service or it can be a OS based application, anything. Yeah, so this is what is the outcome of this particular session. Yeah, so we'll stick to this. We'll keep in mind. Also, one more thing, I'm not going to go in details about algorithms, how AI works and all that. I leave it upon to you and what kind of learning certification and journey you take up. But I'll make sure that no matter which certification or which course you join in, or even if you do a self-study, you will be able to push my ideas onto any algorithm that you might learn down the line in future, and you'll be able to make a generic model out of it, right? So it's a generic proven model. Okay, just give me a minute. I think this keeps popping on the screen. Okay, I'm really sorry. I need to use this to go to next slide. Okay, now I would expect everybody to, so probably this session will be a two-way communication, that it's not only about me talking and you people just listening to the slides. So what I'll do is down the line, after 4 or 5 slides, I'm going to give you some exercise or probably something to think about, that what are we going to do down the line? So there is a small warm-up exercise for all of you, which I have planned, right? Let's see. And I expect everybody to use the chat window and reply me to the question that I've asked in the next slide, right? And let's see what the question is. Just give me a minute. Okay, now the exercise for all of you is on a very simple thing. I have given a paragraph which is written in French. On purpose, I have done this. If you know French, you'll be able to solve the answer immediately. But majorly what I've done is anybody who's entering this domain, anything that has been taught to them is very new to them, or probably they won't even sometimes know that, okay, there is something like this exists. So to keep that scenario in mind, I have put a French paragraph, or I'll say 2 sentences or 3 sentences over here. I know you don't know French, but I would request all of you to think about it, read the whole statement, and let me know what could be the possible missing answer over here, or what could be one particular word, that can come here. And once you give me the answer, also you put your strategy using which you predicted that this could be the answer. So I want 2 things. One is the answer for the blank. Second is a short sentence on the strategy you used to predict the answer. Okay, I'll give you 2 minutes of time. Have a look, and I'll be keeping an eye on the chat window. Okay. I would request everybody to build up a context how you got that answer. I know your answers are perfect, but I'll request everybody to pull the strategy you used to answer that. Okay. I'll wait for another 1 more minute. I want everybody, all 53 participants, to at least give me an answer. Okay. I'm seeing some good strategies coming up. And I hope everybody can read others' answers, right? No. Okay. Also, one simple thing is, if you can give, or probably if you can put your answers or chat to everybody, that will be more helpful if that option is available, right? So that everybody can read what you have written. Okay. Okay, great. So the answer, everybody has predicted it correctly. The answer is Wuhan. Now this, I have got the information from Google. Again, I'm not sure, but probably I don't come to any conclusion that this is the place, but yes, from Google, I found out that this is one district where they predicted that the virus would have started from. And secondly, majorly, I see that everybody is applying a strategy where you are saying context in the sense, even though you don't know French, what you all would have done is you would have gone through the sentence, and wherever you have understood a word which is similar to your learning. Now, what is your learning? Your current linguistic learning is English. Very simple, right? So what you did was you pulled out certain words and you made a dictionary of your own, saying that this is an important word, this is an important word, important word, important word, important, important, and important. Now, since December 2019, so I'll give you a small, backup of this, that what everybody would have done, and this is what we're going to generalize. The thing is, from December 2019, all of you via news, via YouTube, or via WhatsApp, or via newspapers, via chats with your friends and family, medical professionals, you have gathered this information from all of these sources. That means you are learning from December 2019, okay, about this particular problem. And what you have done is you have made a context of your own, saying that if there are words like virus, corona, COVID occurring, the closest words to that is pandemic or Wuhan, China. It is about coronavirus, COVID-19. These all words are somehow related to you now. So that whenever a blank is given to you with all of these words, automatically you are learning from 2019, and you would definitely push one of the words with high probability that the answer is Wuhan here, even if you don't know the language. Perfect. I hope everybody agrees to that, right? So knowingly or unknowingly, what you all were doing is you were all machine learning from December 2019. Now let's assume that this seminar or this workshop that we are conducting, let's say we were conducting this workshop in November 2019. Now you all tell me, if I would have asked you this question in November 2019, there'll be very few people who will be able to even answer, because Corona anyway, this is a strand of virus which is existing from long, but very few of us know that earlier also these cases have come up, but in a small manner, right? So the answers that I got from all of you in strategy wouldn't apply over here. That means a very simple thing is that to any machine or to any automation, you provide some kind of data, relevant data, using which it will do its own learnings. And down the line, in future, when you ask some questions to them, they will try to understand or fetch out these patterns and give you an answer with some probability. Yeah. Please keep this strategy in your mind. This is what we are going to do down the line. This is one example. Okay. Let's take, so this was a linguistics example where you all converted linguistics into context, and from there you gave me an answer. Now let's try to pull out one more example, right? Another 2 minutes I'll give you. Now, what is the thing over here is this is the data or pattern that has been given to you. Okay. Now, these are some future events occurring for A, B, and C, which these are the historic events. This is the future event. Can you please predict the result? Yeah. If somebody can tell me the result, whether it's a leaf or a spade, what is it? Now, this is the data set given to you for your learning. Let's see how many of you are able to pull out the relevant information out of it. Okay. So Neetu, for the strategy part, we'll come back. I'm going to repeat this strategy 4 to 5 times so that it embeds in everybody's, mind. And also, I request everybody, whoever is answering this, if you can tell me again the strategy you used or why you think that club or spade, which one is a correct answer. This is a little tricky. Probably it'll take 2 or 3 minutes of your time, but yes, the answer is hidden in the complete data set. So if you find a pattern, you'll be able to fill it. Okay. Okay, Smriti says club. Smriti, if you can let me know the reason behind that, that will also be helpful. And I request everybody to message to panelists and attendees so that everybody can read your answer and correlate. Otherwise, what's going to happen is people will be clueless when I'm reading the questions. Yeah. Okay, I'll give you a small hint to all of you. One of the attributes, either A, B, or C, is a decision maker. So focus on one of the attributes, you'll find out the answers. Okay. Okay. All right. I'm getting good amount of answers from everybody. Now let me give away the strategy. The thing is, this is a data. That means there are 3 attributes recorded. We don't know what these attributes are, or we are not, as a data scientist, we're not worried about the functional aspect, what exactly these attributes mean. Now I have got 2 answers over here. One is, I'll call it as a leaf, and I'm not sure. Do we call this as a spade or a club? If somebody can help me. The second one, what do you call these as this is a club or this is a club? This is a club. Okay. So we call this as a leaf and a club, L or C. Okay. Now, what are we going to do down the line is we are going to understand that if there is a pattern, see, please remember, there is a question given by me. If there is a pattern, it's not necessary always you'll find a pattern. If there is a pattern. Now let's see if there is a pattern. When this is yes, right? Just observe. When the A is yes, it is the leaf. You can check it out. When A is yes, it is always a leaf, right? It is yes, it is a leaf. And whenever A is no, it is always a club, right? So this is how you can find out if one particular column is reflecting the pattern. Now let's try it out with column number B. Column number B is, if it is no, let's assume if it is no, it's leaf. But whenever it's no, it's also spade. Sorry, it's a club. I'm sorry. So we cannot say with a full confidence that whenever B is going to be no, it is either going to be a leaf or a club. Okay, let's try with column number C. Whenever it's no, it is a leaf. Whenever it is no, it's a club. Again, C is not a very good predictor. So overall, B and C will definitely push some prediction. But if you see, this is a clear winner. And using this particular pattern, you can easily say that it is a club. The answer is a club. Very simple. Yeah. Okay. So whatever we all did just now was pattern recognition. That is that you give me a data with some categories or some numbers with some result. It is, see, please remember the result is very important here because I need something to compare with, or probably if I'm predicting, if I'm saying whenever it is yes, it's a leaf, I need some assurance for that. Okay. So whenever you have this kind of data, all you need to do is you need to do a pattern recognition in a very simple terms. You have to recognize your pattern. And this is what AI or ML or DL, whatever you have heard so far in data science, data analytics, anything that learns patterns is one of these algorithms. Any algorithm you are going to pick up down the line in future when you learn, this is what the algorithm does on the back end. Very simple. Okay, everybody, is that clear now? A quick yes will help. Yep. My only intention to show you these basic examples is for people who are new to this or people who are already doing it, you can always correlate any AI or ML algorithm up to this level. This is the most simplest way in which you can explain somebody what is AI or ML. Okay. Now, once we have learned all of these, I'll give away the secret sauce. Anyway, I keep repeating this. You will see 2 or 3 times, this repetition has happened. Now, the secret sauce for any of these AI or ML related stuff is provide us with a relevant data. Now, what do I mean by relevant data is, if you remember in the previous example, okay, let me go back. Let me skip 2 slides and go back to the previous one. Now, if you remember this particular example that I gave you, the very first sentence was related to AI/ML, which has nothing to do with Corona. I hope all of you saw that pattern. This is irrelevant. This is relevant. Okay. So whenever you are doing prediction, it is very important for you as a data scientist or a data analyst or any other expert who is working on a data related project. It's very important for all of you to pick up a relevant data. Okay, and I'll show you down the line how do we do these things. How do we make sure that the data is relevant? If you take junk data, or if you take data which is not related, or which is not what we require, probably it will not help us to learn anything. No matter what algorithm you are going to use, the best deep learning algorithm you are going to use, you are not going to find any good patterns. Okay, so it is very important for all of us as a data scientist to work a lot on finding a relevant data. This is the, I'll say, the most exhaustive task we are going to have down the line. Next is learn the relevant hidden patterns. This is where AI or machine learning algorithms are going to come. There are hundreds of these algorithms. One of them is going to come, you are going to plug it. The algorithm is going to learn the patterns. That's it. Okay. Next, once you learn the patterns, what are you going to do? You have to store the learnings, right? Correct. So from December 2019, we are all learning about, COVID-19. Where are we storing it? We are storing it on our own brain. In machine, you are going to learn virtually something. You have to go and store it somewhere so that in future, when I come and ask you a question, you are going to retrieve the learnings from here and then show it to me or give me a prediction. It's very important to store these learnings. And in this today's session, I'm going to show you how to do this job. Okay. Next is get the future data. That means in the previous slide you just saw we had yes, we had no, and no. And then I asked you to predict something. That means the result column was empty for future data. That means You are going to use the inputs along with the learnings that you just found from the patterns, and you are going to predict for future. Okay. Okay. There might be a question. Okay. How, with what probability I can say that my prediction is good? We are going to do this when I show you the AI/ML implementation. There is a percentage attached to that. That means if I'm predicting club, right, I'll also tell my client that the surety for predicting club is close to 78%. That means still there is an error of 22% available, which can be a leaf or a spade, as you call it. Got it? So everything is good, but along with that, it comes with the risk. The risk is the probability, the error probability. Okay. Finally, used the stored learnings, okay, to perform your future prediction. So these two steps are clubbed together, and these two steps are clubbed together, and this is an individual step, right? So from down the line, if you want, you can take a snapshot of these. Down the line, any AI/ML algorithm implementation that you are going to do, all you need to do is elaborate each step. Overall, this is what happens in industry. Okay. Great. Can I say that everybody is clear with all these 5 steps? Yep. Quick confirmation will help, because now I'm not going to repeat it. I assume everybody got it. Perfect. Great. All right. Now, breaking the ice, basically, what are these algorithms we are talking about which are going to learn the patterns? So basically, we are talking about a simple machine, which is as simple as a bicycle. You just sit on the machine and you just pedal it away, and it's going to do some job. Similar to that, nowadays there are a lot of algorithms available. Majorly, I would like to say that how do I learn the relevant hidden patterns? If you remember, point number 2 from the previous slide was learning the hidden patterns. How are we going to do this? Majorly, we are going to do this in 2 different classes. That is, one is called machine learning and one is called deep learning. Now, on web, you will find a lot of debate happening that is machine learning a subset of AI, or is AI a subset of machine learning? That's a different debate that we're talking about. Over here, as per me, and also I advise my students and my team onto that, is if I call this as machine learning, okay, that means there is an automation which learns patterns. I classify them into 3 parts. One is called supervised learning. That means if you just remember, I had A, B, and C columns followed by a result. There was a 4th column called result. Whenever you have something to compare your answers with, that means if I'm learning something, and along with that, if I have something to compare, that comes under supervised learning. If the answers are already available for us to check, we call it as supervised learning. Okay. If in case there are places where this answer was not available, if you remember the linguistics French example that we took, COVID-19 example, I did not have any answers for that. Did I give you any answers? Probable answers to learn? No. Correct? In that case, I will call this as unsupervised learning. That means that the reference column is missing. The results column is missing. Okay. And finally, there is something called reinforcement learning. This is a different level machine learning, a set of algorithms where these algorithms learn, they autocorrect themselves, and they come back to normality. That means this is a next version of machine learning. And the best example that I can give you is Google car. If you all have heard about the automated car experimentation that is going on by Google, that if you just sit in the car is going to drive by itself. This is one of the examples of reinforcement learning. So in today's session, I'm not going to talk much about reinforcement because it's a very large topic. We'll majorly focus on to these 2 topics. So once you are clear with these 2, then you can go and sit on to reinforcement learning. Right? So these are straightforward statistical algorithms. Okay, these are pure statistics, I'll say. Okay, which are called machine learning as per me. Second section is called deep learning. Now, this is much talked about set of algorithms nowadays in industry. If you all have seen certain job descriptions or read a lot of blogs, people are now shifting from ML to deep learning. Now, what exactly is deep learning? Deep learning is a simulation of how a human brain works. Very simple. Okay. What do we do is, as a kid, let's say a kid is just born and a kid touches a hot object, right? Immediately it gets a reflex and it registers in the mind that if this is the color, this is the pattern of something, I should not do the job. I should not touch it, right? But to do that, it has to do the action once. It'll understand what is wrong and then it will correct itself or himself or herself, right? This is how a human brain works, right? One more example. If you look at a certain car, right? For example, if I look at a BMW, right? I come to know what brand it is, what color it is, whether it's a sedan or whether it's an SUV, whether it's a hybrid, a lot of things we come to know. How do we know that? Were we born with the learnings of BMW? No. Down the line, when you keep looking at it, keep listening from people, keep reading about it, you try to put some fragments in your mind that, okay, this particular image belongs to a car, which is an automobile. Now, in that automobile, it belongs to a high-end luxury car section. From there, this is the color. So you do a lot of things in your brain by doing a lot of back and forth. And this is what these algorithms simulate, right? So down the line, in the applications part, I'm going to give you an example of both of these, right? About deep learning part. So this is what is deep learning and why it is much more popular or much in demand right now is because of its characteristics to learn. I do something, I understand the mistake and I learn from that mistake. I try to auto-correct myself. Okay. So these are the two major branches which you can think about. How am I going to learn the hidden patterns? Okay, great. Also, do let me know if I'm going too fast or if I'm going too slow. If it's too obvious, you're free to comment on that. I'll try to improvise myself. Okay. Now let's try to, enough of theory part. Okay. Now we understood what exactly is AI/ML, what are the branches of it and how we identify the patterns. Now let's understand what are the applications of it. And I'll not go deep into highlighting all the applications because it is impossible. Even if I take 10-hour session, it is impossible for me to cover all the applications. Like it's widespread now. So few of them I have put it over here. So if I talk about a very popular domain, which is banking, insurance, and financials. Nowadays, you would have seen that, let's say I have an account in an XYZ bank. I have a net banking portal. Okay. You would have seen that when you go to your portal, under loans or offers section, they tell you that congratulations, you have a pre-approved, for example, car loan, okay, of this much number of amount. Right? So for us, it is very obvious, okay, they would have looked at our credit history or they would have looked at my current balance and then they would have multiplied it by some number and give me this number. Right? That's what we would have thought about. But overall, what happens on the back end is bank collects a lot of your data, your transaction history, your credit score, your loans, assets, everything into one place. And finally, using one of these algorithms that we just saw, they come up with a band. That means, let's say this particular customer is eligible for a loan between 12 to 15 lakhs, for example, or 10 to 12 lakhs. And that is what they show on a high-end number over here, that this is an approximate number that you are eligible of. And you all would have seen that when you go and apply for a loan, sometimes this number changes down the line. Okay, so approximately bank is telling you, you are eligible a loan up to 12 lakhs. You might get on approval or on checkout, you might get a loan for 10 lakhs also. We don't know, right? Now, why this is something, this is proven to be good for the banks is, earlier what used to happen is, we used to put a loan application, a number, then a lot of negotiations happen here and there, and then the loan passes. That means the time spent for a customer to apply and to close as a loan, there was a good amount of time there. Now everything is going digitized, and doing this probably in some minutes, you will be able to close this deal, right? And why they are showing you this is because it's pre-approved for you. That means when they checked your data using the pattern recognition, you fall into a section where it is safe for a bank to give you a loan. Your credit score is good. Your payment history is pretty strong, right? So it is automated for a bank where you don't need a person to sit and do this job. A small click for all the eligible customers will do the job. Okay. So from the automation perspective, this is very healthy. This is very quick. Okay. And the decision making is also guaranteed. Going on to the next example. So this is a very simple example I took. Our examples will start getting complicated down the line. Second part is, let's say you belong to a CRM industry, or you belong to sales and marketing, or you belong to a project where you're supporting a lot of clients and you just want to understand some of them are happy, some of them are unhappy. And how do we do that? There are many ways. We collect all the data given by the customer. There could be email feedback, or that could be some kind of support request they put, or there could be interactions with the team. And somehow gathering all this data, I have a result to be predicted, which is happy or unhappy. What if I can create a dashboard like this, right? And convert these customers into happy customers and unhappy customers. Let's just give me 1 minute. I'm really sorry. Just give me 1 minute. There's some disturbance from my side. Okay, I'm sorry. A small distraction. Yeah, so what I was talking about is, what if I can use some historical data about my customers, and I can predict whether this customer is happy or not happy. And finally, I have a dashboard. Probably, let's say I'm a CEO or a senior management of the organization. Every week, I have a dashboard in front of me. By a click, I would be able to group people who are going to retain with us, people who are probably not going to retain with us. And also, there could be people who lie as a mixture over here. That means either we can make them happy, or probably our actions might not make them very happy and they're going to move on. Okay, this is one example. In today's implementation, we are going to take a similar case study like this, where we have some telecom customer data and we are going to predict whether this customer is going to be with us or the customer is not going to be with us. Okay, this is one very simple example. Okay, now let's complicate things. I hope everybody has used Amazon.com. Obviously, yes, Amazon.in, right? Have you all observed when you check out? So this is a live screenshot from my purchases, right? I have a Rottweiler, a 3-year-old Rottweiler with me. And this is what I purchase for my pet probably every month, right? Amazon observes these patterns. When I bought the pet 2 months old, I used to have these things purchased every 6 months because of the size. Now, as the puppy started increasing, probably the food intake also increased. And if you see this, probably in a month, the dog consumes close to 10 to 15 kgs of food. Now, Amazon kept observing these things. And slowly after 2 or 3 purchases, Amazon pushed me to a set of customers who have a pet. So there could be a category within Amazon where they put my profile, right? Now, along with me, there might be many customers, right? Those customers also would have bought these extra products, right? So if you think about it, if this was not shown to me, if you all see this number, if this was not shown to me, I would have checked out at this value. You all agree with that? Right? My checkout value was $18.99. For example, right? Now, since Amazon before checkout, like there is fraction of seconds before I click on this and move to add to cart and check it out. Before that, in that small amount of time, Amazon's recommendation system, this is called recommendation system. It told me that other people also bought this, frequently bought together. Now, if you look at the checkout value from $18.99, the checkout value has become 2,817. That means a close to 1,000 INR bump on the checkout value. Yeah. So can I say that this was something like a virtual sales agent, right? In fractions of seconds, Amazon was able to sell me 1,000 rupees extra worth of goods. I'm not sure how much profit they make out of it, but the revenue, rather than having $18.99 and automation enabled it to 2,800. Correct? Yep. And just for your information, from 2019's data, Amazon was able to push close to 40% of its sales, helped by these kind of recommendations. So look at the number is very heavy. Again, I cannot say that it's the same down the line, but yes, this number is supposed to increase, right? Because if somebody buys an iPhone, the person won't care to go and search for a case or earbuds. Everything should be displayed over here so that at one shot, the person checks out, right? Some people have time definitely to go through, browse, look at the comments and then purchase. Some people trust, this, that, okay, if Amazon is recommending, I think they should be good. They usually are bought together. Yep. This is a small, I'll say, a notch higher than the previous examples, because here, for all of us to think about, there are millions of customers, how Amazon does this job. That is where the beauty of this system lies. Okay. Another example I can give you is Netflix. Okay. Again, I have not put it over here. It's also a recommendation system, but Netflix is also another example where you go, it will recommend movies to you depending on your historical, search patterns. Okay. Coming on to one more good example from Amazon is Alexa. I hope everybody is using Alexa at least, or Google Home, or I can say Apple Siri. Everybody use this, right? How does this work? You talk to this small automation or a bot. The bot processes what you told, it understands what you told, and it tries to give you the nearest possible solution. Let's say if I tell Amazon Alexa that please play Iron Maiden, for example, some albums or some songs from the band called Iron Maiden, right? What Amazon Alexa does is it tries to segregate my words. Please play Iron Maiden. It tries to segregate my words and it tries to find the closest search match in the database. Okay. And also you would have observed sometimes when you talk something, it does not understand at one shot. So you stop the bot and you talk again to it, right? All of these faulty transactions are stored in this bot, and down the line, it is given to, the central database where they try to understand what went wrong and then they try to correct their algorithm. Okay. So you would have observed that once or twice Alexa might make mistake, but after that, when you keep correcting it, it tries to auto learn and tries to give you from next time the correct answers. So this is one example of natural language processing powered by deep learning algorithms, right? Because here we are talking about somebody talking in Hindi, English, or any other language to Alexa. Alexa needs to understand what language it is, and then it goes further to give you answers. If anybody interested in knowing about this more, you can check out my blog. You just put my name, followed by Great Learning, followed by Chatbot, right? You will find a blog along with a code where I have developed a system which is very close to this. Okay, great. All right, going on to the next slide, I need to speed up a little, going a little slow. The final and one of the most complex applications is for AI/ML. I will classify it as computer vision. Nowadays, you would have seen this is becoming very common. Anybody having a smartphone, when you take a picture, along with your face, there is one rectangle that appears. It tells the software that this is where the face is. You need to brighten up or you need to do some edits over there. How does this happen? How from a moving camera, how does that system identify that there is an object over here? This is called computer vision, powered by deep learning algorithms. Okay. Now, in this example, what I've here is anybody who has traveled abroad or stayed abroad for a longer time, you would know that in Western countries, there are a lot of CCTV cameras that are parked on highways or every street. Those cameras are enabled with ANPR, automatic number plate recognition system. That means when your car is moving, the camera tries capturing the number plate or probably tries focusing on this particular area, from where it will try to capture what is your number plate. Now, by doing this, what all you can think about? You can think about understanding whether the car is insured, whether the car is probably there is some issue with the car, there is a case or legal issue going on with the car. If the car was stolen, you can identify where the car has passed through. You can also try to understand who the owner of the car is. In India nowadays, I'm seeing this system implemented on the IT tech parks, where rather than putting a sticker on your car, when the car moves in, from far itself, you come to know whether the car belongs to the tech park, whether it should be allowed. If yes, the shutter or the gates might open. If no, then the gates will remain closed. So it reduces a manual intervention of going and checking for the sticker, talking to the person. It makes the process speedier. And soon down the line, we are also going to get ANPR on our highway tolls and all of these things. Just by looking at the number plate, you'll be able to identify information related to the car. This is a very complicated and classic example of deep learning, right? And there are numerous examples in which you can use computer vision. Another example I can give you is Lenskart, right? This particular website, if anybody has used, it will ask you to sit in front of the camera. It sells basically eyewears. It'll ask you to sit in front of the camera. It'll ask you to move left, move right. It'll try to capture your facial profile, and then virtually you can try their glasses. Either it can be a sunglass or a reading glass, so that you'll come to know. It will give you a live experience as if you actually went to a physical store and you tried all of these. And before buying, you are assured that how it's going to look on your face. If you have not tried it, I would recommend all of you to go and try the system once. This is also another example of computer vision. Okay. Perfect. Great. So now applications of AI/ML is, please remember, if you are thinking about, also one more thing, my internet is not stable. I would like to switch off the video for some time. I'm really sorry for that. Otherwise, there'll be a delay in my voice and my writer. Okay. So I'm switching off my video for some time. Okay. On a very simple thing is, if you all think before joining or before taking up any kind of learnings in AI, if you think whether this is going to help me in my domain, yes or no, then this line is for you. Please remember, any domain that produces digital data, okay, can harness the power of AI/ML to make business decisions. Please remember that. This is a very powerful line. I have interacted with thousands of potential learners where they have a doubt, where let's say one of the examples is, I work in a manufacturing industry. Will I be able to use AI/ML? Yes. If your industry has some kind of digital data, which will help your machine to learn patterns, and down the line, it will help you to take decisions. Okay. So please keep this line in your mind. This technology is open for any domain. And nowadays I see almost all the organizations are digitized, right? So that is where the beauty lies. Okay. So I hope so far so good. You are all now able to connect that down the line. How are we going to use these things? Let me check. Voice is echoing. Can you all confirm me? Is my voice okay now? My net is unstable. Yes, I accept that. If you say still the same issue is persisting, I'll try to shift my network. Okay. Voice is okay now. Perfect. Thank you. Okay. Next is, we are going to talk about now the actual workshop. That means, why are we here? We are here, or probably I am here to show you all how you can transform whatever I just theoretically showed you, how you can transform this into a working model. Okay. Now for me, if I say I work as an AI, or if I work as a principal data scientist, or if I work as a deep learning expert, for me, the whole journey is important. That means how my raw data, or the data which is very junk, or the data that is given to me in the form of some kinds of Excel files or CSV files, which the organization is not sure about, will we be able to get anything out of it? As a principal data scientist or as a core data scientist, it's very important for all of you to understand that how a raw data, okay, So the whole journey of raw data to a self-thinking decision-making application. We just saw Amazon Alexa, right? So when Amazon would have started making it, Amazon would have had some raw data with them, right? So the beauty lies in the craftsmanship here is how do you transform these into a self-thinking decision-making application, which is again powered by AI/ML. Now, why do I say powered by AI/ML? Because the pattern recognition comes from these. Okay. So the prediction algorithm that I just showed you down the line, any of them is going to fit down the line and give you a working model like this. So please remember, the craftsmanship for a data scientist lies over here. How well you are able to convert a junk data or a raw data into a business, a self-thinking decision-making application. Okay, this is what the agenda or aim of your project should be whenever you start up with this project. Okay, next, moving on. Right, so now you will not see much of pictures. You will see a lot of text. You will see some arrows. You will see some flow over here. Now, what have I shown over here is, if you see the infographic in the middle, this gives an idea about a complete AI-based project. Okay, now let me show you what each of these infographic shows. The journey of any of these models starts with the core data engineering team. So over here, you see three folks who are actually sitting and working. I just try to make a feel of it as if we are sitting on the site, or probably they're working on a larger database server or a cloud-based DB application. But all they're trying to do is they are trying to warehouse the data. That means your data might be scattered. Okay, by scatter, what do I mean? Let's say your organization hosts some internal servers which has a lot of data. Also, your client hosts a lot of data on their end. Also, your local teams holds a lot of data on their machines or a centralized server. What if you have to use all of these data together to do some decision making? Let me give an example. Amazon Alexa, when I tell Alexa to do some operation, that means book a cab for me, it has to go to certain outside server. When I ask Alexa to play music, it has to go to one location. When I ask Alexa to talk with me or probably tell me a joke or tell me a story, it has to go to some other place to fetch. Now, what if while training, right, I have to combine all of them into one particular data set? This is what the data engineering team does. Okay, and when I explain you all of these, I'll take some time. I'll ask for your confirmation or understanding, because when I built something in front of you, I assume that you are now clear what does data warehousing means. Yeah. Are you okay with the warehouse part of it? I have data on different locations. I'm trying to pull all the data into one singular data set, right? Also down the line, I'm going to show you the tools associated with them once you are clear with the entire framework. But so far, are we okay with this concept that data can be scattered and it needs to be brought to one particular location? Yes, perfect, great. Now moving on to the second example, to the second task. The second task is backing up the data and managing the data. That means, let's say you and your client has a capability of producing 1 terabytes of data every day, right? You have to do this job continuously. You have to back up your data continuously, and you have to keep managing your data. Managing in the sense, what is the relevant data? What is not a relevant data for me, right? So some data stuff can be relevant. That means if I am looking for Amazon Alexa, I don't need financial data of Amazon. That's of no use to me. So when I fetch all my data, it's very important for me to separate relevance versus non-relevance. Also keep a good backup of this data. Okay. Another example I'll give you is Walmart. We all have heard about Walmarts, right? Walmarts across globe, or probably in US, I'm sorry, not globe, in US, produces terabytes of data every hour, right? So they need a very strong data engineering team who can back it up, who can manage it, and who can warehouse this data with clicks. Okay, so this particular team is very important, and it's I'll say the the most primary team which works on handy data. So these are the teams who help us to provide a good data which can be used for pattern recognition, right? As a principal data scientist or as a senior person in data science domain, you need to have a command over these. You need to at least know how these things work, so that when you find your models are not behaving properly, there is only one thing to blame, and that thing to blame is non-relevant data. So you'll be able to pinpoint what is creating noise, and you need to remove that particular section from your data. Okay. Great. So today I'm going to simulate and show you these things when we build an application. We are going to fetch a live data. I'm going to open a server. I'm going to connect my Python environment to that. We are going to fetch the data live. We are going to manage the data live. All right. So now I assume the output of this particular section will be a singular, or I'll say a combined relevant database or a data set. Now, once you get the data in your hand, what we usually do is the data science team designs the data. That means, as I told you, if Amazon Alexa is in preparation, this particular team will say, I have nothing to do with Amazon's selling. I have nothing to do with how much Amazon is or what product Amazon has. That data is irrelevant for me. I am going to design the data. As a data scientist, you are supposed to tell the data engineering team what you require. Okay. Anybody here from product development or product management background? Anybody who actually manages a product or who's actually developing a current product? If yes, I would say you need to have this particular data design part is nothing but you need to have functionally relevant columns or functionally relevant data. That means if I'm building an application, I need data which is functionally correct. I don't need irrelevant data, or I don't need columns which are not going to affect my product. Okay. It is always good to have huge data, but sometimes irrelevant data creates, unwanted things. So it's something like in this session, what if I start giving you advice on how to appear for interviews? Now that's completely irrelevant to the topic that we are talking about, right? Even though it's a part, let's say it's a part of a good learning journey, right? Or probably it's a success story of how you change your career from current expertise to data science. But for this particular session, it's irrelevant, right? So please think about it. You should not have huge amount of data if you think it is irrelevant to you. Okay. Secondly, you validate your data. Okay. Let me give you an example of what do you mean by data validation. So let me pull in the previous slides. So I'll go back to this slide. Okay. What if one of the columns, in one of the columns, I start writing junk. Let's say if one of the columns was like this, right? You would have definitely thought about that. Yes, one of the columns says, one of the cells says no, but majority of the column is junk to me. That means they do not play any relevant role in predicting output to me. Even though functionally, let's say this B would have been passed by the database team saying that, yes, it has some characters, but we are not experts. You need to tell us if this is relevant or irrelevant. As a data scientist, you need to validate these things. You need to go and manually check it. And today, when we build the application, we are going to see this section. Okay. Let me roll it back to normal. And let me go back to the slide where we were. Okay. So this is something like, even though the data was cleansed or the data was validated by the data engineering team, as a data scientist, what data you require and what not has to be cleaned over here or probably filtered over here. After filtering also, there might be many sections where you feel your data is not correct or probably your data is junk. Okay. At that point of time, again, you have to come and clean your data. I'll give you an example. AI ML algorithms do not understand text. They do not understand computer vision images. They do not understand voice. They do not understand, what do you say, characters, right? All they understand is ones and zeros, or probably some kind of numbers, right? In data cleansing, what we do is we try to, so if you remember in the spades and club example, our inputs were yeses and nos. You think yes and no, computer will understand what do you mean by yes, what do you mean by no? As a data science expert, you are supposed to convert, say, yeses into some high number called 1 and nos into some less number called 0, right? So in this phase, what we do is we convert the data that we have into a data which is understandable by the computer. Or I'll say in this case, understandable by your AI/ML platform. In my case, I'm a Python expert. So I'll say my Python should understand that, okay, this is what the input is. My Python will not understand yes and no. It will not be able to kind of say that, okay, yes is powerful or no is powerful. We don't know. Okay, great. So far, so good. Next, what we do is we do some kind of plots. That means if anybody here from IT industry or industry related to computers, you would know that every month we generate reports, right? We show some graphs. And depending on these graphs, we make a decision whether we are doing good or we are not doing good. We make pie charts, we make bar charts. So if you have, or if your application currently requires, or if your team requires more insights on which particular column behaves differently, or when I interact two columns together, like in our example of clubs and spades, I want to know how A and the result interact with each other. And when you would have plotted this graph, you'd have easily found out a pattern that whenever A is no, it is club. Whenever A is yes, it is spade, right? It is very important for all of us to do this. That means you will get more comfortable with what your data is and how your data is impacting your targets. Some of the projects you would require to make live dashboards. So we just took an example, if you remember, customer, happy customer, unhappy customer. You can use exploratory data analysis to do the job. Now, for all of you, what is exploratory data analysis? On a very simple terms, plotting graphs. That's it, right? I'll show you n number of tools down the line using which you can do this job. Some of the tools might be programmable tools. Some of the tools are just drag and drop tools. I'll give you variety for both of these. Okay. Next, finally, coming to the thing, AI/ML model design. You pick up one of the algorithms, either from machine learning or from deep learning, as per your requirement, your hardware requirement, your software requirement. You pick up one of the algorithms. You design the algorithm. That means you give the input data to this algorithm. Let the algorithm learn the patterns. If you remember the slide that I just showed you, the secret sauce slide, you learn the patterns. And finally, when I give you futuristic data, you predict for me. Okay. So we design and we test the data. That means when I learn my patterns, I also keep some part of my original data as testing data. Now, once I say my model is ready, I plug in this testing data and check that whatever I'm claiming that my model is learning, is it true or not? Okay, and down the line, when we design the model, I'm going to show you how to test it. It's something like you make a product and then you give to your quality team to check it, that whatever we are claiming, is it on the ground or it is just a claim. Okay. Also, this particular task and all of the above tasks are an iterative process. That means sometimes when your models are not performing good, we go back, we again change our data, we clean our data, we check for patterns, and then we come back. So there might be a lot of exhaustive iterations. And sometimes people who are new to this domain get frustrated and exhausted in this case, right? So this thing is going to give you probably more knowledge as you keep building more models. Each model is different because each model has a different data. Do you all agree with me? If, let's say, all of you are from different domains, and if I say that for me, neural networks is the best model, it might not be the case with your current domain because your data might be different from mine, right? So never ever stereotype that, okay, deep learning is always better than machine learning. No. Or machine learning is always simpler than it is not like that. It all depends on the relevance of the data that you have. Please remember that. Okay. Sometimes I've seen some of my teammates or my learners, blaming the model. I would say that's a wrong thing to do it. My models are designed to find out the best patterns. Now, if I'm not able to find the patterns, the only thing to blame over here is my data. That means either I need to stop my project or I need to go back and correct my data. Hope everybody is in sync with me. You all agree with that? Let's spend a minute, to discuss about these. Yes, agreed. Perfect. Right. So please see to that. I'll give you an example. In my last organization, there were some hardware constraints. So basically, I hail from NLP background. I'm an NLP deep learning expert. So I've made n number of automated chat bots and talking bots. Now you'd be surprised to see that I have made a NLP based chatbot just by using a simple machine learning algorithm. So somebody was mentioning Naive Bayes over here, right? Let's say I have done it using Naive Bayes. As simple as that. So when I go and talk to people, they say, whenever I talk about NLP and CV, computer vision, it should be only deep learning. That's not possible. If my data is good, if my data is highly sorted, very organized, a simple machine learning or a simple statistics program from your side will also do the job. Please remember that. Okay, great. Now, once your model is ready, once your learnings are ready, if you remember in the secret sauce, there was the next line was freeze your model. That means you store your learning somewhere so that anybody who requires to use the learnings in future should be able to call them. Okay, so down the line, I'm going to show you how to freeze it using Python. But here, it's all about when I say model freezing, that means whatever patterns I have learned, I'm going to freeze those patterns. In the spades and club example, the pattern was if A is yes, it is a spade. If A is no, it is a club. This was the learning that we got. Very simple. Okay. So this is what is AI/ML model freezing. Now, this is where the data science team's job ends. Okay. The next team that will pick up these things is if in case your organization is a product driven organization, let's say you all are working for Amazon and you have a product which is live, which is a B2C, business to customer product, right? You need to have a software engineering team for that. Now, what does this team do is this team does UI UX design, that is user interface, user experience. It's something like building an application. It can be an Android app, it can be a web service, or it can be an iOS based or a Windows based application. Okay. So there is a separate team of SMEs, subject matter experts, who do this job. Now, once this is done, there could be the whole product might not be an AI based product. So if you remember, I gave you all an example about, let me go back. Yeah, I gave you this example about Amazon, right? So do you think that whole Amazon application or a website works on AI/ML? Is that right? Or there is a small portion of that app when called upon uses AI/ML? Which one you think is the correct answer? Answer number one or answer number two? The whole website works on AI/ML? No or yes. The small portion of the website works on the model learned from AI/ML. Which one is right? Second one. Perfect. So for people who are new to software engineering, we call this as a microservice. That means out of a larger software, there is a small area that I've given to you. To use this area, you have to call the learnings from AI/ML. We call it as microservices. Okay. Now, going back to the relevant slide. Sorry, give me a minute. Yeah. Yes. So we have to design a small microservice, and that microservice, whenever called upon, has to trigger this learnings and call this learnings over here. And I'll show you today how to do this live. Finally, followed by application testing. So we go through a lot of exhaustive testing like functional testing, non-functional testing, security testing, load testing. A lot of tests are done on the software engineering. We are not going to do this today because it's not a part of the session, but yes, this is very important because you are bringing in stuff from outside. It has to be foolproof that the way it has been designed here, the same way it works over here. So in let's say in our case, it was A, B, and C followed by a result. Now in the production environment, if it is A, B, C, D, let's say if there are 4 columns, the model was trained on 3 columns, but in production, you are pushing 4 columns onto it. This model is going to collapse. This model is going to give you an error because the frozen learnings are only for 3 columns. We are not having learnings for the 4th column, right? So a good sync and testing is very important between both the teams. And finally, you have to deploy these applications. So currently there are 2 types of deployments. One is a cloud-based deployment. Another is a local environment-based deployment. That means if you have a client, if you have client's production environment, you send your team of experts who can package these applications into one clickable file or one executable file and go and dump it on the production environment. Okay. Or else when you look at the cloud part, we think about, or you would have heard about AWS, you would have heard about Azure, you would have heard about MongoDB, Oracle. There are a lot of platforms on which you can go dump the application. And when somebody goes and accesses it, all the supporting files are present on the same or probably accessible folder so that the whole application runs flawless. Okay, this is called application deployment. Again, it's not a part of today's session, but yes, I'll give you a touch of it because it's very important for all of you to know this, how it works. And always, this is a very curious side for a lot of my learners that we want to learn. We know what is this, but now we want to learn how to deploy them, right? How to make it as a clickable product. Great. Can I say you all are kind of familiar with these three domains now? Data engineering, data science, software. I'll not say you are an expert at it, but at least can I say it's a high level understanding, 50,000 feet view. So if I ask you software engineering, you know what it does. Perfect. Great. Now we will go to the application part. So anyway, these slides I have explained you. So whatever we are talking about now is each domain I have taken and I've shown the details of it. So here we have some raw data, which can be an alphanumeric data, text data, voice data, image data, or video data. Any data, anything that is possible to train a model can be listed over here. Say it is given to a centralized server. In today's demo, I'm going to show you MySQL. We are going to work live on MySQL relational database. Okay. I will use MySQL to store all of these as tables and then plug it into one singular table and give a singular validated data set as an output to me. Okay. Now, what are the steps? Connect to various locations of data where it is hosted. That means there can be many places where this data might be hosted. Check syntactically. Validate the data, whether the syntax is okay, the columns are okay. If you feel there is any junk column, remove it. There is a limitation with this team because sometimes it has to depend on the data engineering team whether to take a decision, whether this is a junk or it's usable. Combine all of the data into a singular data set. That means merge. Anybody here from DBMS background will be able to correlate it very easily. You have 2 different data. What if I can merge them into a single data? I'm going to show you now how to do this. And finally, maintain the data pipeline. Now, what do I mean by pipeline is down the line, once your AI/ML model is in production, you will continuously need this data. Why? Because say today there is a pattern of data given to me, my model was trained onto that. Tomorrow, the pattern might change. Do you all agree with that? I'll give you an example. Let's say we are talking about a company which makes hand sanitizers. Okay. Now, till November 2019, the sales and the production of these hand sanitizers, masks, gloves company was say X. Post December 2019, that X has become Y now. And you all agree to that it has shooted up exponentially. So whatever machine learning I would have done on this scenario will not work on this scenario now. Do you agree with that? Yeah, data has changed. Your machine needs to be relearned. And for that, I need to keep my data available in the pipeline. Correct? So let me now, enough of theory. We will simulate this in a Python environment. Okay. If you feel I'm going fast, do stop me. I'll try to, explain you in depth. Okay, just give me a minute. Let me check if I have the data set. Yes. So what I'm going to do is we'll pick up one current problem, okay, from a live problem from industry. And let's wait for a second. MacBook and Excel, doesn't usually go hand in hand. Yes. If you all are getting confused, do stop me. But before going on to this weird looking, confusing data set, let me give you the context. I'll switch on to the whiteboard. Company X has approached, for example, Great Learning. I'm just giving a hypothetical example with a problem statement. Now, Company X is a telecom-based company. Okay? It is a telecom player. Let's say it has approached the data science team, which is led by me. Okay. And they are asking me that I have got a huge amount of customer data with me. Okay. And every month we are keeping a tab on this, saying that if this is one customer with some data to it, to himself or herself, whether the customer is retained with us or the customer has moved out this month from our services. This is my result. Yes and no. The customer is with us or customer is not with us. And these are my learning data. If you remember ABC from our cards example, this is my ABC and this is my result. So the company is now confused that using normal graphs, I'm not able to predict anything. Why? Because if you look at this data is exhaustive. The example that I gave you in my presentation, there were only 5 rows. It was easy for you to find patterns. Now you tell me, if I give you 25,000 rows and say 100 columns, will you be able to find patterns easily? And the answer is going to be no from all of you. I agree. Yes. Okay. So the company is now in a dilemma that none of my existing graphs and tools are able to give me patterns. Will you be able to help me out? So when this problem statement comes to me as a principal data scientist to my team, what I usually do is we are going to simulate now. Okay. So the first thing that we have over here is we have got some kind of data. And when you look at this data, you won't find it pleasing to your eyes. And again, I'll be very upfront with all of you. If you are working in core data science industry, the data is not pleasing. And when the data is not pleasing to your eyes, that's an indication that you have a good data. Please remember that. It's a paradox. If your data looks weird, if your data looks confusing, that data is good. If your data is straightforward, that when you look at it, when you look at 25,000 rows, and if you are able to predict with your naked eyes that, okay, this is the answer, then I will say that is a made up data. Please remember that this is coming from my experience. Okay. So industry data is usually mixed up, jumbled. It will not give you good patterns, but that is a good data. Okay. Now, when you look at this data, I'll take you through some of the columns. Let's say this is the customer ID of the customer. This is the gender of the customer. The customer is senior citizen, yes or no. So if I use my filters over here, you'll be able to understand what options we have. 0 is for not a senior citizen, 1 is for a senior citizen. Next, let us take the internet service they are using, whether it's DSL, fiber, or they are not using the current internet services taken by us. Like that, we have got n number of columns, which is captured by the hosting company. That is the telecom company X, which has approached me. One more example, payment mode. How this customer is paying. Is it a bank transfer, credit card, electronic check, or a mail check? Okay. Like that, the final column is whether the customer is moving out, no, or the customer will be moving out? Yes. That means from next month, there are chances that the customer is moved, or in this data set, this is an actual data that this customer is moved out this month. So the target column or the result columns here we are focusing is called churn. It has only two options, no or yes. Are we clear on the data set part, everybody? Crystal clear? What are the learner columns and what is the reference column or result column or target column? Right? A quick yes will help us, because now I'm going to refer churn as my target column always. Okay, great. Now let's simulate these things. Now to simulate the entire data warehousing part, what I have done is I will launch my local server. So I'm hosting a local MySQL server. Okay, just give me a moment. I'll start it live. Okay, so now my local MySQL server has started from my end. You guys will not be able to access it. It's a local server. Okay, now let me get on to a workbench. So to do scripting, to use this service, I have, just give me a minute. Okay. Now inside this, what I've done is I have imported the tables. I just showed you one table, if you all remember. Sorry, I just showed you one data set. The customer, the data set that I've received, the churn column and the prediction columns. So this is my centralized data set. Now to simulate all of the things that I showed you in data engineering, I have divided the data into two parts. Some of the columns are hosted in one table called telecom churn 1. Some of the other columns are hosted in telecom churn 2. Right? When I package, so when you dismember this whole data set, the data set that I just showed you in the combined manner, when you dismember it, or probably when you make it into two parts, assume that customer churn 1 is coming from one team and the other part of the data set is coming from other teams. So I have got now two separate tables which are hosting the data of my interest. Okay. And if you ask me, what is this interface? This is a MySQL workbench where I'm writing a small SQL script where I'm saying select everything from this particular node, which is called Krishnav. This is my node. And inside my node, there are many tables. Your company might also have different tables where different projects or different people are storing their data. I am currently looking at a node, which is called, I'm looking at a table, which is called telecom churn 2. So I'm writing a small script to extract all relevant data from my side. Okay. Now what I'll do is I'll show you some good clickables using which we'll be able to do the data engineering job. Okay. So just bear with me for a minute. I will run my Python code. You don't have to worry about the Python code. Are you all able to see this small piece of application on my screen? Is it readable to everybody? Yes. Yes, perfect. Okay. Now, what am I doing is whatever I did using these logins and whatever I showed you in this PPT, right? Whatever steps I showed you, we are going to simulate it using a clickable app. The very first thing is asking me for the host name. So probably this is your IP where your data is stored or where the server is located. But for me, it's a local, so I'm putting local host. The name is, username is root. The password I'm going to type is something like this. Okay. Now, which node we are looking for? So if you remember, the node we were looking for was Krishnav. Krishnav. Okay, I'm going to say that please go to this node. Okay, and connect my current application to the database. So now if you see here, this is a typical jargon which Python throws back, confirming us that the connection has been established at this particular port from my machine. Okay, so far what I simulated was logging in or connecting my machine learning pipeline software with the database. All right. Next, it is asking me what you want to import. So now, as I know, I have only two tables. I am going to script. So if I go back to my Python SQL shell, this was the script that I wrote to extract this table. Okay. All I'm going to do is, rather than using MySQL Workbench, I am going to say that there is something called telecom churn 1. You please extract everything for me and store it. Okay, 1 minute, just a minute. We will redo this task. Okay, so this is where my application is hosted. Now you'll observe when I write my SQL script like this, and when I say execute, you would have seen there is an Excel file which is built up. What I have done is I have imported my table from the database into my local machine as an Excel file. You will see one more time. When I run for table number 2, you will observe over here, I'll get DB2. So I'm now importing locally both the tables which were earlier hosted on my servers. These are the 2 tables which are earlier hosted. Now I have it on my machine. Okay, so far, so good. Next thing, what I need to do is I need to warehouse my data. I need to merge my data. There are 2 different tables which I need to merge to become one table. When I click on this, you will find, I'll have an Excel file now, which is nothing but my merged data set. So when I open it, now you will be able to see all the columns. These are my learning columns, and this is my target column. Clear, everyone? So far, you don't always have to take a tough route of going to DB and scripting hard. You don't have to do that. This is called an ML pipeline. You know what the project is, you know what your data set is, you keep it ready so that in future, with one click, you'll be able to execute everything. You don't have to go and write these long codes. So if you see that app that I'm showing you, this is the backend code which is going around. I don't expect you to do this. Everybody needs automation. Okay. Next is basic cleansing that has to be done. That means you will find some of the columns or some of the rows that are empty, right? So when I click on that, I'm asking my automation to tell me, do we have any empty values? Do we have any cell which is empty? They told me there are 121 cells, which is close to 0% of the total data set. It will be 0.000 something. From 25,000 rows, if 121 cells are empty, it's negligible, right? You will agree with that? It's a negligible data, which is empty. So what I'm going to do is I'm going to drop them. I'm going to say, we are going to remove those empty cells. We don't want to take a risk of keeping them. Okay. And it is giving me a confirmation that we have dropped it and we have exported the file. We have overwritten the merged file with the new file. What is a new file? The file which does not have empty values. All right. Next, I'll open up the file again. Now, as I told all of you, Python or any of these machines don't understand what is female and what is male. Agreed, everyone? How am I going to convert these things into something which is understandable by Python? I told you all, right, that we are going to use some methods to convert text into numbers, right? There should be some strategy behind it, correct? So let's say for my project or for this particular table, I am saying we will use a technique called label encoding. That means I am going to convert male as some number, female as some other number. Okay. If you see here, it says done, exported to Excel. Now let me reopen the file. The same data set now. Okay, just a minute. Yeah. Are you able to see male, female, or are you able to see any categories available now? No. What I've done, I've used a technique within Python, which will help me to give a number to certain text. So now I can say that this will be easily understandable by any computer because it's in numbers. Correct? Everybody is in sync with me? Understanding this is important. Again, I will not ask all of you to strain you or strain you all to tell you what is this label encoding. Please, you can do this once you learn AIML. But the overall task was what? That there were a lot of categories there: male, female, payment modes, yes and no's. Even if you see the churn, yes and no has converted to 0 and 1, if you all can see that. Right? 0 is given something, 1 is given something. So from now on, if I say churn 0, it is something, churn 1, it is something else. Okay. Can I go further? Yes. Great. Finally, what I have done is just to understand what we have now, I have got 7,000 rows and 21 columns. I've just a small data analysis from my side. It's not needed again, because as a data expert, you would have checked this before starting with this data set. So this is one small automation which comes under data engineering. So these data engineering teams, or a team which, or a person who is a full stack developer like me, will have these handy, so that tomorrow, if your customer says, I've got new 7,000 rows, you don't have to write these lines of codes. It's a waste of time. You make a pipeline which is common. All you need to do is give these details and do some clicks. Within 1 minute, you'll be able to make your data production ready. Getting the point? Now, what was the outcome of this, this particular slide? Singular validated data set. Do we have that with us in this form? We have it. Exactly. If you want to go one notch further, what you can do is you can have one more clickable here. When you click it, this singular data is going on a server where data science team is working. That means you are replacing this with their existing data set and telling, please relearn. The data is new, relearn. Okay, we'll come to that that thing later. So this was one sample clickable that I wanted to show you to emulate, or probably to simulate, this particular slide. Because when you see something handy, right, when you see something live, you'll be able to connect yourself better rather than me just reading through the lines. Okay, can I move to the second, the data science team, the next slide? Are you all okay with this? Yes, perfect. Now, for this particular team, which is called the data science team, the input was the output from the previous slide. That is a singular data set for learning, relevant data set for learning. Okay. Now, I already explained what all we do under AIML. That means we import the data, we clean the data, we do some kind of graphs, we train the model, we improvise the model, then we freeze the model. Now, how do I put everything into one clickable? That is what I'm going to show you now. Whatever I explained you in detail, let's make a clickable out of it. So for that, and also I would like to go to the root folder, and I would like to delete some of the files, because this is what is the output of this code. Okay, so if you see here, the merged data that I had from my previous output is already present here. With one click of mine, that thing got exported here. Now let me run this clickable. Right. Are you all able to read this? I'm really sorry because the font is very small, but that is what by default comes with Python. Okay. Now this particular thing will simulate what a data scientist will do. So I have kind of replaced a machine learning engineer here. This is called AutoML, automation, machine learning. I'll say software or a clickable. It is asking me for an input file. What do I have? I've got merge dataset.xlsx as my input file. Okay, when I click on import, no matter what is your extension, it imports your file and it confirms you, yes, we have read your input file. Now it is telling me, tell me your target column, the column which I have to refer. Can you all tell me what the column name was? The result column. Exactly. The answer is churn. There was a column called churn, if you all remember, which was yes and no. So I am saying that from this larger data set, you have to refer your models that we are going to implement with this. Okay. When I click on import, it says I have found it and I have registered it. Now I have some simple machine learning algorithms predefined over here. With one click, I am going to perform machine learning and it will display you the results over here. Let's try with an algorithm called logistic regression. Now you will observe that I have got some numbers over here. Train accuracy is 79%. Test accuracy is 79%. So what do you mean by this is, I'll go back to whiteboard. See, anything that a machine learns, right? You need to validate it. You need to check whether this is right or wrong. You cannot blindly say that, okay, I've learned all the patterns. It's not possible. And that also on a junk data like this. This is a very complex data that we have picked up today. It's not a very simple data. It has a lot of unwanted patterns also, right? What do is we take the whole data set, we split it into two parts, say 70% of the data and 30% of the data. This 70% of the data is used to learn patterns and store the learnings. Now on these learnings, this extra 30% of the data is given, and whatever answers are produced as predictions, we come back and compare with the actual answers present in this data. The churn that was present in the test data and the churn that was predicted, we compare them. And that comparison output is 79%. Correct, everyone? When I trained my model, I was able to get 79% accuracy. That means predicted churn versus actual churn, 79 of them were same out of 100. That means 21 hours were still different. Same was on testing. So when your test and train accuracies are very close, you can say that model is very stable. Getting my point, everybody, why I did that test and train split? You cannot give the whole data, right? We will not be able to measure it. How do I measure these things? So this is a measure quantity for me. So like that, let's run some other algorithms. So there is an algorithm called naive Bayes, 75, 75. My algorithms are very, very close. Let's try support vector machine. So like that, I'll just put some technical jargon here. You don't have to worry about these, but overall, when I run this, this is a little complex algorithm as compared to the earlier two. It tells me my training accuracy is 73. My testing accuracy is 74. That means in test environment, it performs even better. Okay. So like that, let's run one more. So I'm running an algorithm called decision tree. Okay. So when I run it, it gives me 78% train, 79% test. Okay. Let's try one more. Just writing on some technical things here. When you learn these algorithms, you'll come to know what exactly are these. So let me put 20. So when I click on run, it'll take some time, but yes, now I've got 78, 78. And finally, the most powerful algorithm, it's called adaptive boosting. I'll call this as 20. I've got 80% train accuracy, 81% test accuracy. Okay. So now let's say as an organization or as a team, you had a limitation of putting only these algorithms in place, hardware, software, a lot of other technical skills, a lot of other constraints you had, and you were able to push it only on these. Now, can you tell me which of these machine learning algorithm you would prefer to use down the line? Which one is one of the best ones that you feel over here? Okay, I got an answer. ADA is the best. Great. ADA, all right. Okay. Now, when you choose ADA, you have to tell your client that, see, in my environment, it's 80, but in your environment, it's 81. So client will be happy anyway, right? So accuracy wise, descending order is the highest one. Stability wise, you should always pick up the algorithms which train and test is exactly same or very same. Okay. So you have algorithms like logistic and naive Bayes where accuracies are low. I agree. 79, 81, there's a huge difference, but train and test, that means what you are making in your home, the same behavior is going to happen when you go out. See, it's something like, I'll give you an example. So I have a 6-year-old daughter. Okay. Now my daughter is a Python coder. She does basic Python coding. Yes. Now, when she's sitting in front of me and I give her a problem statement, she codes, she is in a comfortable environment to do it. She might ask me, I might give her some solution. But let's say if I tell to the world in a competition, when I take her out and I say that there is a 6-year-old Python coder, you give any problem, she's going to code it. She is going to definitely get nervous here. She might lose some edge, or she might need some help, right? So let's say if she say out of 10 lines given by me, she's able to code 9 properly in my home, in an environment where she's comfortable. In a non-comfortable environment, she might go up to 5. This is a huge difference. Look at the accuracy. Accuracy was very high, yet this is not a preferable model. So like that, you need to aptly choose which one you are going to go further with. Now comes, how do you freeze the learnings? You will remember the last step. The last step for any machine learning or any data science project was to store these now. Okay, you have learned everything perfect. Now, how am I going to share it with the world? For that, you will observe when I click on execute, you will observe some files getting generated here. You see that? These are my frozen models. Or else, in a very simple terms, these are the hidden patterns that these algorithms identified out of the data. This one of them, so let's say some of you said ADA boosting. This has to be taken and thrown it to the software engineering team. That has to be given it to them. That for your futuristic microservice, please use these. Are we okay with this? If you ask me what is this extension, what the file is, that is very technical. There are many ways in which you can generate these learnings, but at the back end, these are the pattern. Are we all okay with this? Can I go further? So Kiran, yes, gradient boosting can be done. So there is a question from Kiran. I particularly like this question is, gradient boosting can't be done in place of ADA. Yes, Kiran, we can do it. This is just a demo file, right? Usually I ask my learners to go further. That means increase the number of algorithms here so that you have got 15 to 20 ML algorithms, and then you choose the best out of it in fractions of minutes. Getting my point, Kiran? So this is just a demo. Okay, even you can put deep learning over here. Deep learning algorithms like neural networks will do a beautiful job here. Okay, so I want learners to take it further. All right. Okay, so now we have finished working. So data science team has done the job, and the frozen model is ready, which is ready to be exported outside. And when I clicked on execute in my previous app, you will find that the model is thrown away. So personally, I like random forest. I am a big fan of this algorithm. And when you learn it, you'll come to know why. It's a very stable algorithm. So the learnings of random forest are manually exported here with a click. Okay, and what is this? This is the place where your app is stored, where the software engineers have put all of the supporting files for your app. Now, what is that app? Let me show you. Let's go to the next slide. The next slide is the software engineering. That means the data science team designed an AI/ML model, and that particular pattern is now coming as an input to a small microservice that we are going to design. Okay, now let me show you the app. So let me kill this app and let us go to the actual deployment. Again, the codes are very heavy, so I don't expect all of you to have a good grasp over that immediately, but this is how the app looks like. Now, what are these? Can somebody tell me what are these? The attributes that I have there. These are nothing but the features that were present on your input data. Gender, senior citizen, you all remember these columns, right? Now let's start using them. Now, if you ask me, what does this app do? Let's say in the CRM team, customer relationship management team, or the sales team, there are certain people who are given a task that we propose that these set of customers, let's say we give them data of 10 customers, they might churn out. Can you please check whether this is correct or not? That means I will have an executive under me whom I'll say that please check for these 10 people, there's a new data generated, and tell me whether the customer is going to retain or the customer is going to churn out. Please tell me. So for that, what the executive will do is executive will start clicking on the values that we have here. So these are the values given by me, assume. So I'm giving some junk stuff, okay? Let's say I have told my executive that these are the values and my executive is currently inserting those values live on each and every column. And what are these things? These things are coming from the data team that see, these are the attributes attached to one of the customers. Monthly charges 500, total charges say 3,000, for example. Now, this is the data the executive has, what executive has inserted. This is the future new data that has come. Now, for me, I have to use my previous model. So if you remember, give me a minute. If you remember, we generated a model called randomforest.sav. If you all remember that, which got exported from our data science team. This model, I am unpickling it. That means I'm unfreezing it. And using that unfrozen model, I'm predicting. On what I'm predicting? I'm predicting on this as an input data. The data that I've just given here, I'm submitting it as an input data. And then I'm using the unfrozen model to predict. Predict to me whether this is going to be yes or no. So when I click on predict, you will find that it'll take some time. It will find out all of these things and it'll say that, stay assured, this customer is not going to churn out. Okay. Right. Everybody saw that? Straightforward. Now you also can think about why the executive should fill the column. By one click, all the columns should be fetched from the DB and autofill. Yes, you can do that also. With one click and the customer ID, the executive should be able to fill all of these automatically. For that, you need to develop a different set of application. For me, the current app is I wanted to show you something live. So it's clickable. I have given some menu options here and done some animations. You can make this app more fancy. This is a very, very basic layout app. But at least it's telling me that with I think random forest accuracy was 78. With 78% of probability, I can assure you that this customer is not going to churn out, but there is a risk. 22% of error is still existing in our model. If you remember the app, the AutoML app that we just designed, 78 was the random forest accuracy, right? So the customer has to take a risk of 22. In that, they can take a decision whether to approach this person and give more offers, right? So they can strategize their business. So this is the decision power that we are giving it to a business. Getting my point, everyone? This is how the raw data, we took up some junk data from DB and we converted into a business decision. Yeah. Okay, I'm seeing your questions. Give me some time. I'll put it in the Q&A section. Okay, great. So yes, I need to kill this. Just give me a minute. This is going to annoy for some time. Yes, and we are going to kill this manually. There is some issue with my Python. Yeah. Okay, so this is what we have done so far, and you all understood how this is done. Now, finally, wanted to discuss one more extra topic with all of you is your data might change every day. Do you all agree with that? Let's say today you designed this model on X data. After 15 days, the client says, I have got Y data now. That means that the data is very huge, 10 times of X. Should we retrain? Yes, you have to retrain your model. You have to continuously integrate and continuously develop your model. Anybody here understands CI/CD, DevOps, if you've heard about? Continuous integration, continuous development. This is an unending process. Why? Your data keeps changing from X to Y. If your data does not change from X to Y very often, your current frozen model will do the job. But if there is a big difference, right, you have to continuously integrate and develop or redesign your model. And to do that, we also have one more app in place. That is, I have an app in front with me, which will help me to find out whether my old data and new data has difference or not. So let's say every 2 days you get data from your client. And I assume that the data coming from the old data was one on which I designed my model. and the new data given to me by the client is 2, which I need to check whether it's same as 1 or not. If it is not same as 1, I have to redesign my model. If it is very close to 1, you don't have to redesign anything. Your learnings will be good, right? So what I'm going to do is I'm going to input them. I'm going to tell my model, my app, that please import this data and please import this data. Okay, all done. Now my app has read both of the data. Now comes the comparison. I have to compare them. Now, I will not reveal how I'm comparing it. That's again a very technical stuff, but there are many methods in which you can compare two things. You all know. Simple subtraction, simple comparison, probabilistic comparison. So all I'm doing is I'm running a test here. Oh, sorry, I have to enter the name of a column. Okay, let's open up and enter the name of a column. Let's say I pick up a column called senior citizen. I want to check. Let's say we thought that, okay, this column is very important on my target and I need to check whether it has changed or not. Change or not between what? These two. How different 1 and 2 is with respect to senior citizen column. When I run my test, something went wrong. Just give me a minute. Give me a minute. Something is wrong. Okay, I'll just kill this app and I'll rerun it one more time. The final output should be same or not same. Very simple. Let's try one more time. Okay, and yeah, it's running. So far, so good. Senior citizen. Okay, I think it's throwing some error for me. It's having an internal error. Okay, for an overview, what the output was supposed to be, the output was supposed to be similar or not similar. Okay, so I've used some technique on the backend to find out the similarity or dissimilarity. So this will give you a trigger that whether I need to retrain or I don't need to retrain, right? And whatever applications I showed you can be in a pipeline. That means an automation which can open an app, fill all this data, click, take the outputs to the next application, do the job, take it to the next. And when it comes to this one, if it was dissimilar, again, re-trigger the whole process. So you don't need any human intervention here. This can be easily automated and put it in a continuous integration, continuous development loop. If anybody is new to this, you can go and read about DevOps. Okay. Great. So this was a clickable ML pipeline that I wanted to show all of you. And along with that, I ran some simulations, so that you can correlate. Okay. So majorly, this is what happens. And it again changes depending on your organization and your scenario. But this is the backbone you can think about.
Okay, Krishnav, I just wanted to inform you that we have a few more minutes left for the session. Also, I think the screen is stuck. There might be some lag. Okay, I think Krishnav has dropped the session due to, okay, he's here. Hi, Krishnav.
I'm really sorry, my internet snapped out.
That's completely all right. Just wanted to inform that we have a few more minutes left for the session.
Yeah. Yes, I'll complete within 5 minutes and then we'll open it for Q&A. Yeah. So I was just talking about this. You guys can take a screenshot of these. It's all about understanding how you can connect this entire ecosystem with one of your simulation tools. So today I showed you Python. There are n number of tools available, which is R, Java, Spark, Julia, PyTorch. There are a lot of tools available. So this was the deployment. These were popular libraries. This is what continuous integration, continuous development. This is called virtualization. I just told you that we can with one click, you will be able to manage the whole system. The complete connectivity of all the tools that I just showed you, all the clickables I showed you, complete pipeline. You can do it using virtualization. You can fetch your data, warehouse your data, a lot of things you can do. So again, this is what my CV looks like. You can definitely, take this path of learning, or else you can just be a data science expert, data scientist, and you have people who can connect all of these to your tools and take it forward, right? So this is just an example. Now, keeping the time constraint in mind, let me go to the next slide, which is your question. So I will keep this at the last. Okay, let me just check if I have anything else pending. Yeah, so I think nothing from my side. I think we are good to go. Now I'll keep it open for your questions. Okay, so let me go through the chat window and let me answer the questions for you.
We also have a few questions, Krishnav, on the Q&A tab, if you want to take them.
Yes, I've opened both the tabs. Okay, so there is one question from Smriti is, can you provide a source of reinforcement learning? Smriti, yes, officially from Great Learning, not possible, but yes, you can go to Great Learning Academy. It's a free application that we have developed, and you can definitely find out some topics on reinforcement. Else, if you don't get it, YouTube and Google is one of the best sources, especially the blogs like Medium or the Data Science, Geeks for Geeks. There are a lot of blogs available. You can start from scratch learning, right? Next is, how did you become a data scientist? Okay, this is a personal question. Yes, I'll try to answer that. So there's a question from Kostubis. How did I adapt to data science? I like to on my screen if I'm visible now, and if my voice is clear. My data science journey. So basically, I started as a full stack. I started as a developer, then moved on to testing. And then later on, after 2 or 3 years of that stint, I got my hands on to Hadoop. So I started my career with big data analytics, and then I shifted to data science AI. So it was a gradual journey, but what I did is I kept my core competency, which is coding and testing, automation, RPA. These all are my core competencies. I kept them as core and I overlapped it with data science. So if you look at any of my implementations, they'll be very close to IT services, softwares, all those things. So you also can do that. If you're an experienced person from a domain, you keep your core as your competency as your core. And on the top of that, you layer it up with AI ML and you do all the applications on that domain rather than shifting it to a generic data science domain. Okay. This is how I did it. And also I took so I'm an alumni of Great Learning. I passed out in 2018, right? Official certification of data science and deep learning expertise from Great Learning itself. So that was my, inspiration, to get on to it. It was a 12-month course and I did it. And along with my job, I did it. And yeah, it was a tough journey, but yes, the reward is very good. Right? So anything new is definitely, it'll take some time, but the learning curve depends on you, how you want to do it. Right? If you're dedicated, if you can spend half an hour, 1 hour every day learning these things, I think 5 to 6 or 7 months down the line, you'll become, you'll become an entry-level person in this domain, and down the line, with your core expertise, you can rise up. It's all about taking a problem statement and converting into a business decision. Okay. Yeah. Next is, how do you practice on real time? So if you've heard about Kaggle, everybody, right? Kaggle hosts a lot of data set and competitions live, right? This is how you can practice it up. Yeah, or else you can take up one of the certifications from some of the prestigious organizations, which will help you, because when you take up a certification, right, it's something like you have to complete it. And to complete it, you have to give some projects, submissions, thesis, and these theses are nothing but your real practice. Yeah, so that's another way to make sure that you get going. Okay. Everyone I know is getting in the field of AI, ML, data science, etc. But I'm not sure if I want to dive deeper into field. How can I be sure of it? Please remember that down the line, almost all the organizations are going to adapt automation. And when you talk about automation needs somebody to give them the triggers. And the trigger, the decision trigger, is coming from data science. IoT, if you've heard about IoT, right? So it's something like you are working in office and you just move out of your office and from your phone, you can click, say that, keep my geyser on, keep my cup of tea, the tea machine to be on. If you have kept something in microwave, keep it on so that when you reach home, it's hot. It's something like IoT. And when you have to do this kind of decisions, a smart brain or probably a machine brain is required. And the machine brain is nothing but AI or M. Okay. Great. Yeah.
We are a little above the time that we have for this session.
Okay.
But there are a lot of questions that are popping up that I can see. But I think they can catch hold of you at the lounge section. They can ask all these questions. If you want to take one last before we end this session, then
Okay.
yeah.
So there is one question is how freshers having an academic background in operational research can carry a data science. So Aniket, very simple thing. As I told you, your core competency will be ops. Now in operations, what you need to know, you need to have dashboards, you need to have places where you find issues like something like defects, right? Let's say in your team, if somebody is not working that great, and how do you get to know? By analyzing the timesheets, the deliveries. What if you can have an automation driven by AI/ML to pinpoint that this person at this particular point of time is an issue for your ops? So this is the blockage for your operations, and I often do that. I do allocation to my team depending on an automated dashboard. So if some work comes to me, I'll come to know which team member is busy at what domain. So by one click, it'll recommend me which team member is good for this role or probably this job, and has some bandwidth to do that job. So yes, as I told you, your core competency is your academics or the domain that you come from, wrapped it up by an automation powered by AI. Very simple. Yeah. And if anybody wants to connect with me anyway, I am present on LinkedIn. So you can just type my name. You will be able to find me on LinkedIn. You are free to connect with me. If you have any questions, we can also take it offline. No problem at all. I'll be happy to help all of you in any way, any career advice or anything where you are stuck with. I'm open to that. Expect some delays from my side because I get a lot of questions on this, but yes, I'll definitely reply to that. Yeah. So with this, I thank all of you, for giving time, your time for this particular thing, and I hope I was able to show you what exactly AI/ML is from scratch. Some of my examples might be very simple, but yes, you'll now when you go to a complex level, you should be able to put my example as a base. As I told you, have a relevant data, learn a pattern, and freeze the pattern. That's all is AI/ML. Yeah. So I thank all of you and I wish you all the best. Stay safe and keep learning. Thank you.
Thank you, Krishnav. It was a great informative sessions. We are already getting a lot of appreciation from on the chat box. Thank you for doing this with us. Please get in touch with him for whatever questions, and all the best for a data science career. Thank you, Krishnav.
Thank you.